What we're looking at today is Thecta. Thecta is a 500 kVA, 645 kilowatt hour battery energy storage system. Its use case is both on and off-grid applications. This particular one is for EV charging for a customer that has a limited grid supply. So it'll be coupled with 200 kilowatts of solar. At the end here, you can see the DC rectifiers for the EV charging. So it's a 360 kilowatt EV charging set, which goes to 6 guns. In the next area is the 200 kilowatt solar inverters. Underneath there's a few deliverables for the customer when it goes to site, coolant for the chiller, ducting, ventilation. In the next cubicle is fire suppression. So that big red tank is connected directly into the battery packs. So in the event of a fire, that gets released and suppresses the fire. Coming up here are the batteries. So there's 645 kilowatt hours in total, split over separate racks. At the top of the racks, there's a BMS that talks to the master BMS, if you will. It's all high voltage. There's fire suppression, smoke detection, cameras, everything in each of these bays. When we walk around the corner, you can see the chiller. There's a large chiller for keeping the batteries cool. Now, this is definitely a nice thing to have. Some systems are passively cooled or air cooled. Water cooled is definitely the way to go on a system like this. As we come around the corner a bit further, you'll get to see the next rack of batteries. So same again, 5 packs in series up to the BMS, and then the BMS goes to this cabinet next to it. Now, the cabinet next to it has DC distribution in the top, AC distribution in the bottom, and on the front there's a screen to show all the battery parameters. This is a 500 kVA piece of power conversion equipment, so that's doing the AC to DC conversion. And then in the last bay is an isolation transformer. And what this is for is some extra safety for grid protection. It's not required in every country, but for this particular customer it is. One of the things I've noted as I've been walking around looking at this system is it's very well built. All the doors are insulated. There's some real consideration for ventilation so that you can see the power conversion equipment has a huge duct at the top which drives the hot air straight out. So it's cold air in through the lower ducts there, and then forced air driven out the top. All the other zones all have ventilation as well. They all have insulation. It's a very compact unit. A 20-foot container jam-packed with 645 kilowatt hours is very impressive. And what I think makes this unit very special is lots of container storage systems. Everything's on the inside facing inwards, and so you enter the container as an occupant with the door open and you're in there with it. With this design, everything facing out, it's a lot safer. So for anyone maintaining it or working on it, you're limited only to the cubicle you're working on, and you've got nothing behind you. So in the event that anything goes wrong, it's just a much, much safer design.
So yesterday I was in the factory city Hezhou in China, where these containers were built, and I followed them to Hong Kong, and I'm going to show an installation, where they're installed, why they're here, how they work, and just give a bit more information because it's suitable for many applications.
What we're looking at is an EV fast charging station. Now, this fast charging station in Hong Kong has a limited supply. It's got a 315 kVA pole top transformer, and of that, only 80 kVA is available for charging these free stands. And what the client wanted was 360 kVA of EV charging. So anywhere up to 120 per unit, so quite a lot. The containers over here are the ones I showed yesterday with 500 kVA of inverter power, 645 kilowatt hours of energy storage and a 500 kVA inverter. You can see there's an EV charging here now. What's going on at the moment is a bit of a commissioning exercise. So there's some cabling on the ground here, but not to worry, it's only temporary for commissioning. So over here, what you can see is the power conversion equipment, how many kilowatt hours have gone out today, total kilowatts real time, Some graph data here. Up here you've got run lights, power alarm, and this is what I was showing yesterday as well with the really good ducting and equipment. And then over here is BMS data. So we're looking at cell voltages, temperatures, state of charge. Voltage data, state of charge, temperature. This is really, really good. This thing sounds like it's just kicked on a little bit harder. Yeah, so it's using 3.2 kilowatts, so not a lot at the moment, but I'm sure that'll come up quickly as the cars start to charge.
To summarise, Thecta is perfect for on-grid applications, including peak demand and EV charging, as well as off-grid applications where you might run solely off grid and solar and still want some really big outputs for, say, EV charging or even running a commercial facility.